Okay, so question number 1 for our practice test is going to require us to do long division. We can't use synthetic substitution because of this coefficient in front of x, so we have to use long division. So whenever we're doing long division, we put our divisor 2x plus 3 out in front, and then we check to make sure all of the terms are present in this other polynomial. So we start with the fourth power cubed squared x to the first power constant, so we don't need to add in any missing terms. So I'm going to set this up. And then I'm going to start, sorry, that's a little sloppy. I'm going to start with dividing. So when you're dividing, you always divide the first terms. So we're going to divide 4x to the fourth power by 2x. 4 divided by 2 is 2. And x to the fourth power divided by x is x cubed. So then I take that answer and I write it up above. And that's division. And now our second step is to multiply. So I'm going to multiply 2x cubed for 2x and also for 3. So 2x cubed times 2x is 4x to the fourth power. 2x cubed times 3 is 6x cubed. So step 2, multiplication. Now step 3 is to subtract. So we're subtracting 4x to the fourth and 6x cubed. So when you subtract, you change the signs for both of those terms. So this is now a negative 4x and this is minus 6x cubed. So when you bring down 4x to the fourth power minus 4x fourth will cancel. Negative 10 and negative 6x cubed is negative 16x cubed. So after subtracting, you bring down and you're going to do that same procedure again. Division, multiplication, and then subtraction. So starting again with division, we're dividing negative 16x cubed by 2x. So negative 16x cubed divided by 2x. Negative 16 divided by 2 is negative 8. X cubed divided by x is x squared. So you write negative 8x squared on top. And then multiply again here, and we're going to write it underneath. Negative 8x squared times 2x is negative 16x cubed. Negative 8x squared times 3 is negative 24x squared. So after multiplication, we're going to subtract, which means we're going to change both of these signs right here. So this is going to become positive 16x cubed and positive 24x squared. Again, bringing down these cancel. 4 plus 24 gives us 28x squared, and then bring down plus 10x. And then start again. 28x squared divided by 2x. Show that work here. 28 divided by 2 is 14, and x squared divided by x is x. So we're going to write positive 14x or plus 14x up above, and then multiply. 14x times 2x is 28x squared. 14x times 3, we don't know 14 times 3 in our head, we can show some work. 42. So we get plus 42x. And I'm going to subtract. Again, changing the sign and changing the sign. These cancel. 10 and negative 42 is negative 32x. So after subtracting, bring down, and we'll do that one more time, starting with division for our first terms. Negative 32x divided by 2x is negative 16, because the x's cancel. So we write negative 16 and then multiply. Negative 16 times 2x is negative 32x. Negative 16 times 3, I can show that work, gives me negative 48. Then, again, for subtraction, you switch the signs. This becomes positive. This becomes positive. So these cancel. Negative 41 plus 48 is positive 7. Whoops, I almost put a negative. So it's positive 7. This is your remainder. The remainder is written above with this divisor right here, 2x plus 3, as the bottom of the fraction. So remainder goes on top, and then this 2x plus 3 is on the bottom. We put plus this fraction because my remainder was positive. So it looks like my answer is B. Okay, number 2. Given a polynomial and one of its zeros, we're going to find the complete factorization of the polynomial. So complete factorization really is just telling us to factor completely. So because they're giving us one of the zeros, we can actually use synthetic substitution and use synthetic division to find out what the other like divisors or the other factor. But I feel like, at least in my class, we have enough information, so we are just going to go ahead and factor this using the grouping method. So anytime you see 4 terms, you're going to factor using the grouping method. So you're going to group together the first 2 and then group together the second 2. So in my first 2 terms, I'm going to divide out the GCF. So looking at 169 and 49, we want to divide out, or not 49, 845. We want to divide out a number from the largest number from both of those. And then we are definitely going to be dividing out x squared. So 169 is actually can be multiplied to get you to 845. So we are going to go ahead and divide out 169 x squared. So just as a heads up, on the test, the numbers are a bit smaller. So don't worry too much. Okay, so 169 x squared, we're going to write down, open parentheses, and divide it away from these first 2 terms. So 169 divided by 169 is going to cancel. X cubed divided by x squared is x to the first power, because when you divide, you're ultimately just subtracting these exponents. 3 minus 2 is 1, so x to the first power. Negative 845 divided by 169 is 5, because 169 times 5 gives you 845. So dividing that out, it's minus 5, and the x squareds cancel. Then over here, we're going to do the same thing, factoring out GCF. Since this is a negative leading term, we want to divide out the negative. And then 49 can be divided out from both of these numbers. Again, smaller numbers on your test, so don't worry too much about needing to know that these large numbers. So we're subtracting 49, take that number out, and then open parentheses again. Negative 49 divided by negative 49, those will cancel to leave us with x. 245 divided by 49 is 5, because 49 times 5 gives us 245, and it's minus because the positive divided by negative. Okay, and then we remember our factoring by grouping method. What we're going to do is we're going to bring together these numbers that are multiplying in front of parentheses, and that is going to become one of our terms. And then when you're factoring by grouping, what you have in parentheses will always be the same factor. So those always are the same, so that's one of your factors, x minus 5. So they want us to factor this completely. This is not factored completely. X minus 5 is, which by the way, they told us x equals 5 is one of our zeros, so x minus 5 should be one of our factors, but we can actually factor this further. This is the difference of 2 perfect squares, so it is going to follow the formula a plus b, a minus b. And the reason why we know we can use this formula is because you can take the square root of 169x squared nicely, and you can also take the square root of 49 nicely and get good numbers. So to find your a term, you do the square root of 169x squared. So you do the square root of your first term. The square root of 169 is 13. Square root of x squared is x. So my a value is 13x. Then to find your b value, you do the square root of the second term. The square root of 49 is 7. So then we're going to plug those numbers into the formula, a plus b, a minus b. So it's 13x plus 7 and 13x minus 7. And then don't forget about this x minus 5 as well. So your answer is B. Number 3, we are given f of x and g of x, and they want us to choose the expression that is equivalent to f of x minus g of x. So for f of x minus g of x, we are going to be taking this expression and subtracting this expression, or this function. Okay, so when we're subtracting with these polynomials, what happens is we need to distribute this negative to all of these terms after the negative. So we start by copying down 5x squared minus 9x minus 1. And then right here, by distributing the negative, it's going to be negative 10x squared. Distributing negative here is negative 3x. And distributing the negative here is positive 2. So it switches your signs over here when you distribute that negative. So now what we're going to do is we are going to combine like terms, starting with our degree largest exponent. So we have 5x squared and negative 10x squared to give us negative 5x squared. We have negative 9x and negative 3x. That gives us negative 12x. And then negative 1 and positive 2 is positive 1 or plus 1. So my answer is B. Number 4 is asking what are the x-intercepts of the graph. So another word for x-intercepts would be our solutions. The solutions will tell us the x-intercepts. So what we're going to do is we are going to solve. So when we solve, we are going to try the factoring method first. Okay. So back to what I was saying. Sorry about that, you guys. The easiest way to solve or find x-intercepts is to factor. So we're going to try to factor this. The first thing we want to do to make our lives easier with factoring is we want to take out GCF. So we can actually divide out 2 before we start. So that would leave us with 2 and then open parentheses, 2x squared. 14 divided by 2 is 7 with x, and then 6 divided by 2 is 3. So after that, we're going to factor these 3 using our procedure. So what 2 terms multiply to give us 2x squared? That's going to be 2x and x. 2 terms that multiply to give us 3, and we're going to add up to positive 7x, would be 1 and 3. So multiplying diagonally, x times 1 is 1x. 2 times 3 is 6x. These both need to be positive to add up to 7x. So this should be plus 1 and plus 3. So my factor would be 2 times 2x plus 1 times x plus 3. So once you're done factoring, you set your factors equal to 0, and then you will have your solutions or your x-intercepts. So this factor out here, if we set that equal to 0, we're not able to solve for anything, so that doesn't help us. 2x plus 1 equals 0. I'm running out of room right here, you guys, so I'm actually going to use a different sheet of paper to finish this one off. So I'm going to subtract 1 to both sides, and I get 2x is equal to negative 1, and then divide by 2 to get x by itself, and negative 1/2 is my first x-intercept. And then over here, I'm going to set my other factor, x plus 3 equal to 0, and then solve. So subtract 3 to both sides of the equal sign, and x equals negative 3. So my answers are negative 3 and negative 1/2. Those are my x-intercepts. So you factor and set your factors equal to 0. Number 5, what are the solutions? So similar to what we just did above, you would always try to factor first to find solutions. That's the easiest method. But if you can't factor, when you have this quadratic function, you would use the quadratic formula. So that is what we are going to use to find our solutions in this problem, because this is not factorable. So I'm using my quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So we're going to identify a, b, and c from our equation here. So a is 4, b is 5, and c is 2. So I'm going to take those numbers and plug them in right here. We have opposite b, or negative b, becomes negative 5 plus or minus the square root of b squared minus 4 times a times c. Sorry, c is 2. That's my fault, you guys. And I can't find my whiteout. Cool. Sorry about that. That's a 2. And then this is all over 2 times a. Okay, so negative 5 plus or minus 5 squared is going to give us 25. Negative 4 times 4 is negative 16, and negative 16 times 2, if you want to see the work for that, we get negative 32 or minus 32 all over 2 times 4, which is 8. So to continue simplifying under the square root, 25 minus 32 gives us negative 7. And then I'm going to break this apart. We have negative 5 divided by 8, and it's also going to be the square root of negative 7 divided by 8. But the square root of negative 7 we are going to actually rewrite as I square root 7, because anytime you have the square root of a negative, it comes out and that becomes I. And then again over 8. So 8 is dividing this and this term right here to get this as our answer, so we have A. Again, underneath the square root, when you have negative, just bring it out and write I. Okay. Number 6, which product of factors is equivalent to this? So there's different ways you can do this problem. I'm going to show you the way that I would do this, and this is actually not going to be enough room, so I am going to use another sheet of paper as well. So what I'm going to do is I'm actually going to simplify this a little bit. So if I rewrite this, it would be x plus 8 times x plus 8, because that's what x plus 8 squared means, multiplying it to itself. And then we're going to subtract y squared from that, and then we're going to simplify by combining like terms. So x times x is x squared, x times 8 is 8x, and 8 times x is 8x, and 8 times 8 is 64. Minus y squared, so combining like terms, x squared stays. 8 and 8 give us 16x, plus 64 stays, and negative y squared. So what we're going to do is we're going to see which of these 4 would give us this when it's simplified. Okay, so I will go ahead and start with A. A, if I were to distribute and multiply all of this out, I'll do it up here. X times x, if I distribute it, would give us x squared. X times negative 8 is negative 8x. And x times negative y is negative xy. And then distributing negative 8 over here would be negative 8 times x, which is negative 8x. Negative 8 times negative 8 is positive 64. And negative 8 times negative y is positive 8y. Then distributing the y gives you y times x, which is xy, and then we'll add a plus in front of there, and then y times negative 8 is negative 8y, and y times negative y is negative y squared. So if I were to combine like terms, the x squared would stay. Combining negative 8x and negative 8x give us negative 16x, and I'm already going to stop because this should be positive 16x, and it's negative 16x, so I know A isn't going to work. I could have seen it back here too, where I started to get negative 8x and negative 8x. There's no way that would have added to give us 16x, so you could have seen it then as well. All right, part B is x plus 8 plus y times x plus 8 plus y. Because it's this squared, so we rewrite it like this. Let me switch my pen color because that is running out. So I'm going to do the same thing. I'm going to distribute. X times x is x squared. X times 8 is 8x. X times y is xy. 8 times x is 8x. 8 times 8 is positive 64. And 8 times y is 8y. Then I'm going to continue going. Y times x is xy. Y times 8 is 8y, and y times y is positive y squared. I'm going to stop right there because when I combine like terms, I end up with positive y squared. It doesn't combine with anything else, and I need negative y squared, so I know my answer is not B. So if I rewrite part C, it's x plus 8 minus y times x plus 8 minus y. That's what that means, multiply it to itself. I'm going to go ahead and skip over to if I were to multiply this whole thing, and if I multiplied negative y times negative y, I would end up with positive y squared to be that last term, because the negative times the negative is positive. So positive y squared is not going to give me this at all, because it needs to be negative y squared. So I know my answer is not C. So I know my answer is D, because if I were to multiply this whole thing out and combine like terms, I would end up with this. So let's show that work. X times x is x squared. X, and this is part D. X times 8 is 8x. X times negative y is negative xy. Then distributing 8. 8 times x is 8x. 8 times 8 is 64. 8 times negative y is negative 8y. Now I'm going to distribute y. Y times x is xy. Y times 8 is 8y. And y times negative y is negative y squared. So combining like terms, I have x squared that doesn't combine with anything. 8x and 8x is going to give me 16x. So far it's looking good. Then I have negative xy and positive xy. Those are going to cancel each other out. This is a negative 1 and a positive 1 coefficient, so those are going to cancel each other out. I have positive 64. That has nothing to combine with. And then I have negative 8y and positive 8y, which again are going to cancel each other out because of the negative 8 and positive 8 as the coefficients. And then my last term is minus y squared. And that is what I wanted. So my answer is D. Number 7, we're going to describe the end behavior for this graph. So when we're talking about end behavior, it's asking where the function is going to be rising or falling on the left and rising and falling on the right. So we're looking at the shape of the graph by determining the degree, whether it is even or odd, and we're going to look at the leading coefficient. So what we do to figure out the shape of the graph or the end behavior is we look at the highest exponent. We look for that degree. The degree is the largest exponent. So we're going to focus on this term right here. The degree is 6, and that would give us an even degree. So when you have the even degree, it means you're going to have the same end behavior. So what it means is for even, we're either going to start where it's rising, so starting and ending rising up, or it's going to start and end going to the bottom. That's what the even degree tells us. Same end behavior for my function. The leading coefficient is negative 4, which is a negative number. Since it is a negative number, it means that my end behavior is going to be facing down right here. It's going to be going to negative infinity. Okay, so anytime it's even, it's either both going up or both going down. Because it's negative, it flips the graph upside down. So it's going to have negative for my function's end behavior. So what we're going to look for is my function approaching negative infinity and negative infinity. So this says f of x approaches positive infinity as x approaches negative infinity. So anytime it says x approaches negative infinity, that's really just looking at the left side of the graph. So if I were to graph x approaches negative infinity, talks about this direction, going what happens on the left side of the graph. And then, so all of that means the left side. And then when you see positive infinity or no sign in front of infinity, meaning positive infinity, that's just going to talk about the right side of the graph. So as x approaches positive infinity just means on the right side. So like we mentioned over here on the graph, this is where our function is going to be facing down for both of our end behavior. So we're looking for, as x approaches negative infinity, my function's approaching positive infinity. That's not what we want. We want the function to be approaching negative infinity because it's going down. So on the left side, as x approaches negative infinity, my function is going down to negative infinity. So far, that's good. Then it says the function approaches negative infinity as x approaches positive infinity. On the right side, my function is also facing down, and that's what I wanted. My answer is B. This says that the function is down on the left and up on the right. That's different end behavior. That would be for an odd degree. And then right here, my function is going to positive infinity, function is positive infinity. That would be same end behavior for a positive leading coefficient, so that's not it either. Number 8, what is the solution to the following system of equations? We're going to be solving using combination. This is not ready to be solved using combination because of this. 5x needs to move over to be in front of negative 3y. So to move over the 5x, we're going to subtract 5x to both sides. So this second equation becomes negative 5x minus 3y is equal to negative 6. So you always want to have it in standard form to use combination, which means x plus y equals number, x plus y equals number. So I'm going to rewrite those over here. 8x plus 2y equals 4. And then this new equation, negative 5x minus 3y is equal to negative 6. So what I want to do is make the same coefficient, one positive, one negative, and I can easily do that for my y's here. I can also do it for the x's, but I think the numbers will be smaller for y's. So what I'm going to do is I'm going to multiply the top by 3 so that I get positive 6y, and then I'm going to multiply the bottom by 2 so I get negative 6y. Okay. So when you multiply, you have to make sure to multiply to all your terms. So this is 24x plus 6y is equal to 12. The second equation, negative 10x minus 6y is equal to negative 12. So when you add down, 24 minus 10 is 14x. This is canceled and this is canceled, so it's equal to 0. 12 minus 12 is 0. Then you divide by 14. 0 divided by 14 is 0. So I have the first part of my answer, 0. But let's go ahead and show how to find the y. Once you have x, you take it and plug it in for one of these equations. I'm going to go ahead and plug it in to the top equation. So here's the top equation. I'm going to replace x with 0. 8 times 0 is 0. 2y is equal to 4. Divide by 2. 4 divided by 2 is 2. So that is how we get 0, 2 as the solution. Number 9 is we're going to be factoring. So what we need to be able to identify is that this is a perfect cube and this is a perfect cube. So this is our difference of perfect cubes, and it follows a formula that we all should memorize. It's a minus b times a squared plus ab plus b squared. So this is a formula that is always used when it's the difference of two perfect cubes. And you can memorize the little helpful hint SOP, which means same sign, opposite sign, plus sign. And that helps you with your signs in your formula. So this will always be the same sign as what's given, so negative, opposite sign, so it becomes plus, and ending in a plus sign. That's how SOP can help you. So we're going to identify the a by doing the cube root of the first term, meaning what times itself will give you 27a cubed. That's going to be 3a. And then to get your b term, we're ignoring the negative in the middle there. We're going to take the cube root of the second term. That means what number times itself gives you 8. So we get 2c. Because 2c times 2c is 4c squared, times 2c is 8c cubed. So I'm going to take each of those terms and plug them in. It's going to be a minus b, and then a squared would be 3a squared, which is 9a squared, that goes here, plus ab means multiply these together. 3 times 2 is 6, and then ac, just rewrite together, multiplying. And then b squared would be 2c squared, which means 2c times 2c, that's 4c squared. So based on all of these answers, I know my answer is B. Number 10, what is the product of the numbers? Product means we are going to be multiplying these together. So when I do that, I have 11 plus 10i times 3 minus 15i. I'm going to distribute. 11 times 3 is 33. 11 times 15, if we can't do that in our head, that's okay. I get 165. So minus 165i. 10i times 3 is positive 30i. And 10 times negative 15 is negative 150i squared. Oh man, not having my white out is just not cool right now. Okay, so I multiplied all of that out. I remembered 10i times the 15i gave me that I squared over here. So we're going to go through and simplify this. The 33 is going to stay. Negative 65i and positive 30, those are different signs, so we're going to subtract them. 165 minus 30 is 135, but keep the sign from the larger number, so it's minus 135i. And then negative 150i squared, we have to remember that I squared equals negative 1. So it's actually negative 150 times negative 1, because I squared just means negative 1. So right here, I get plus 150. So my last step is combining these. So I get 150 plus 33. I can show that work. 183 minus 135i. Your answer is C. So again, we have to remember I squared. This is actually a real number that will combine with the 33. You just need to change that sign by plugging in the negative 1. Okay, number 11. The synthetic division below is representing our function divided by x minus 5. That's why they plugged in right here the positive 5. And we're going to choose a value for m so that x minus 5 is a factor. So when I have a factor, that means my remainder equals 0. So what we're looking for is this number right here. This is our remainder. We want it to equal 0. So whatever number we plug in for m should give us 0 in order for this to represent x minus 5 being a factor. So what you could do is go ahead and plug those in for m, do the work, and see which one gives you 0. But I'm going to go through and do, I think what might be a little bit easier. So they started by bringing down the 1, and then they multiplied to get 5, added down, multiplied to get 40. And if you add down right here, you get m plus 40. Because you can't combine those, you add them and just rewrite it here. So following the synthetic division, you would multiply 5 times m plus 40. Let's use some parentheses because you're not only multiplying by m to get 5m, but you're also multiplying by 40. 5 times 40 is 200. And now we add down. So a negative 190 and this, the 5m is going to stay. Negative 190 and 200, different signs subtract, keep the sign from the larger number, gives me plus 10. So what I want right here is it to equal 0 since they want to show 5 as a factor. So you take that expression and set it equal to 0. So then we're going to solve and then divide by 5. M is equal to negative 2. So your answer is D. So you're just following your same steps for the synthetic division. It's just you're going to have an expression that you set equal to 0 at the end. But again, another method that some kids might want to use is if you plug in 2 right here and do your synthetic division, you don't end up with 0. If you plug in 3, you don't end up with 0. The only number that would work for M that we have here would be negative 2. Negative 2, if you plugged it in right here for M, added down, multiplied, added down would give you a remainder of 0. Number 12, we're going to write the equation in vertex form. So what we want to remember is vertex form looks like this. Completing the square is going to help us do that. So we want to remember completing the square utilizes our b divided by 2 squared formula that we want to make sure that we have memorized. So I have this equation, and if I want to complete the square, I'm going to start by setting it equal to 0. So I have x squared minus 14x minus 16, and I'm going to set it equal to 0. and then I'm going to complete the square. So in order to complete the square, you have to first move over the negative 16 by adding 16. So I have x squared minus 14x is equal to 16. And then I'm going to add a number to both sides to complete the square. So that number that you're going to be adding to both sides is using the formula b divided by 2 squared. This came from our last section. B is negative 14. So when I plug that in, negative 14 divided by 2 squared is negative 7 squared, which is 49. So I'm going to be adding 49 to both sides. When I do that, I am now going to rewrite this as a square binomial. So if you were to factor this, it would be x minus 7 times x minus 7, which is x minus 7 squared. Or use the shortcut that says take this and divide it by 2, and that would be this number right here, that coefficient divided by 2 would give you the minus 7. So that's going to be squared, and that is equal to 16 plus 49, which is 65. So the last step would be to move the equal sign back over. To get it equal to 0, you would subtract 65 to both sides. You don't combine anything over here, you just rewrite it as x minus 7 squared minus 65. So your answer is A. So we complete the square, write the square binomial, whatever it's equal to, just move it to the other side by switching the sign. Okay. Number 13, which of the following polynomials could represent this graph? So we know that in a polynomial, the roots, these x-intercepts are the roots, and these are the solutions. So if I have x equals negative 2, and I have x is equal to 3, I'm going to write those in factors. When we write these in factors, we have to switch their signs. So I know one of my factors is going to be x plus 2 because we changed that sign, and one of my factors is going to be x minus 3. But it is very important that we understand that this root or this x-intercept is a turning point. Because it's a turning point, it means that x minus 3 has a multiplicity of 2, which means it happens twice. We need to add in the squared at x minus 3. So my answer is C. So we find the roots, plug them in by changing the signs, and the multiplicity of 2 happens here because that's a turning point. Number 14 is asking us which ordered pair is the vertex. So to find the vertex, we have to memorize the formula. X is equal to negative b over 2a. Once you get x, you just plug it back in to find y for your ordered pair. So b, or a is negative 5 and b is 30. We're going to be using that. So x is equal to negative 30 over 2 times negative 5. So we get negative 30 divided by negative 10. Negative 30 divided by negative 10 is 3. So x equals 3. I'm going to go ahead and plug that back in to find my y. Negative 5 times 3 squared plus 30 times 3 minus 11. Order of operations, we do our exponents first. Negative 5 times 9. And now I'm going to multiply. Negative 5 times 9 is negative 45. 30 times 3 is positive 90 minus 11. And then I'm going to subtract 90 and negative 45. Those are different signs, so I'm going to subtract and keep the sign from the larger number. So it's going to be positive 45 minus 11, and 45 minus 11 gives me 34. So I have 3, 34 as my vertex. Need to memorize this formula, negative b over 2a. Number 15, we're going to find the product, which again means we will be multiplying, which we can see these, not exponents, parentheses next to each other means multiply. So what I'm going to do first is I'm going to distribute negative 7k over into the parentheses, and then I'm going to distribute positive 4 over into parentheses to give me a total of 6 terms. So negative 7k times negative 6k squared gives me positive 42k cubed, because negative 7 times negative 6 is positive 42. K to the first power times k squared gives me k cubed. Negative 7k times 3k is negative 21k squared. And negative 7k times negative 6 is positive 42k. Then, I'm going to run out of room. 4 times negative 6k squared is negative 24k squared. 4 times 3k is 12k. And 4 times negative 6 is negative 24. So what I'm going to do now is just go in and combine like terms. Right here is 42k cubed. Then I have my k squared terms. I have negative 21k squared and negative 24k squared to give me negative 45k squared. Then 42k and 12k is 54k. Oops. 54k minus 24. So my answer is C. Number 16, we are looking for the one of these that is equivalent to this expression. So what we're going to do is we are going to subtract. When you subtract, you distribute the negative and change all of the signs following the negative. So I'm going to go ahead and copy down 12p minus 4p cubed minus 1. Distributing the negative gives me negative p cubed plus 6p minus 6p squared. So again, just change these signs following the negative. So starting with my highest exponent, I have negative 4p cubed and negative 1. We know this is a negative 1 out in front. Same sign, add and keep the sign. I have negative 5p cubed. Then looking at my p squared, I just have negative 6p squared. Then my p terms, I have 12p and 6p to give me 18p. And then copy down the minus 1. That negative 1 has nothing to combine with here. So my answer is A. Number 17, we're looking for the graph that represents this polynomial function. So based on the factored form of the polynomial function, we know we're going to have x-intercepts or roots at these solutions, at these roots. So you take these numbers out of parentheses and switch their signs. So we're going to have a root at negative 3, negative 1, and positive 1. Because to solve, we would set these factors equal to 0 to get these answers. So this is where my graph is going to cross the x-axis. But because of this x plus 3 squared, I know that this is going to be a turning point on my graph. Because of the multiplicity of 2, I'm going to come down and then just touch at negative 3 and then not pass through it. So we're going to make sure that that is a turning point on the graph. So with that, we are going to check to see where we have these as our x-intercepts. Also, what we can look at is the degree. So the degree of this polynomial would be 2 plus 1 plus 1. Remember, you add those exponents on the outside for your powers of x. 2 plus 1 plus 1 is 4. So this means that my graph is an even degree. Since it's an even degree, I'm going to have the same end behavior. It's either going to be opening up to the top or opening down towards the bottom. Because it's positive leading coefficient, this positive value out in front, it's going to be opening up. So I'm looking for that graph with the same end behavior going towards positive infinity, and this is a turning point and these as my x-intercepts. So that would be B. Because A has a turning point at negative 3, It does have an x-intercept at -1 and 1, but it opens down, which means it is a negative even degree, and the negative even degree is not what we have. We have the positive. So our answer is B, because we have a turning point at -3, passing through -1 and +1, and my end behavior goes up towards positive infinity for both. My answer can't be C because -3 is not a turning point, and right here as well cannot be D because that is not a turning point. Number 18, we're going to factor. So whenever you have 4 terms, you are going to factor using grouping. So always check for GCF first. There's nothing we can divide out before we start. So we're going to go ahead and just group these first 2 terms and the second 2 terms. So looking at your first 2 terms, we're going to divide out 3 from both terms and also r squared, because that is the largest term that you can possibly divide from both of these. So you start by writing that down, open parentheses, and do your division. The 3's cancel. R cubed divided by r squared is r to the first power. -30 divided by 3 is -10. R squareds cancel. And then over here, there's no GCF. There's nothing that we can divide out from r and also from 10, so we're going to use 1, +1 to divide out. So you write down +1 because we can divide out 1 from both of these. That leaves us with r divided by 1, which is r, and -10 divided by 1, which is -10. Again, factoring by grouping, the parentheses, what's inside will always be the same. That's one of your factors. And then the numbers that are being multiplied out in front of those parentheses merge together to make your other factor. So these are my factors: 3r squared plus 1 and r minus 10. Number 19, we're going to consider the functions f of x equals -x plus 6 and g of x equals this quadratic parabola. So they are already graphing g of x for us because that's the parabola. This is going to be a line, so I'm going to go ahead and graph that. To graph this, you start at the y-intercept, which is 6, and then my slope is -1 over 1. So from my y-intercept, I'm going to go rise -1, run 1, down 1 over 1, down 1 over 1 for my slope, so that I have it graphed. So this is my f of x, and they are asking for what values of x will these be equal. And that really, if we just have the graph, would be where the graphs intersect. So at what values of x, where do those graphs intersect? So we have them intersecting right here at x equals 2 is going to be our first answer. And we have them intersecting right here at x equals 5 for my second answer. So my answers are A and C. Number 20, we're looking for the function with a degree that is odd. So an odd degree, we know will have different end behavior. Let me switch the color of that. Odd degree means different end behavior. So the graph is either going to be positive infinity on the left and negative infinity on the right, or vice versa, where it's negative infinity on the left and positive infinity on the right. So I'm going to go ahead and eliminate C and D because those are even degrees because they have that same end behavior happening. We're looking for different end behavior for our odd degree. They tell us that we're going to have a negative leading coefficient, which means the graph is flipped upside down and it's going to be falling. So it's going to be starting up at the top and ending down at the bottom. So we're looking for the graph that does that. So our answer is B. This would be our negative odd graph because it's falling down, going towards negative infinity. This one rises going towards positive infinity. That would be the positive graph. That's why we did not pick A. We're going to solve this function. So when we're solving the polynomials, we're going to use a procedure for factoring, and then set your factors equal to 0. So every single time I'm factoring, I always want to check for greatest common factor that I can divide out first. So looking at all of these terms, I cannot divide out anything before I start. So I'm going to go ahead and jump into my procedure for 4 terms, which is factoring by grouping. So I'm going to group together the first 2 terms, then the second 2 terms, and then do my GCF. So for these first 2 terms, the largest number or coefficient I can divide out is 5 from both of these. And then I can also divide out x squared from both terms. So I write down 5x squared, open my parentheses. 15 divided by 5 is 3. X cubed divided by x squared is x to the first power. Negative 10 divided by 5 is minus 2. X squared cancel. And then we're going to do the same thing with these 2 terms. We can divide out a 2, positive 2, because this is a positive leading coefficient. So I write down plus 2, open parentheses, 6x divided by 2 is 3x. Negative 4 divided by 2 is negative 2. There it is again. We have these same expressions that come together to give us one of our factors. And then out here in front, 5x squared plus 2 merges together to give us my other factor. So here are my factors. What I'm going to do is I'm going to set each one equal to 0. So I have 5x squared plus 2 equal to 0, and 3x minus 2 equal to 0. And then I'm going to solve for x. So for here, I'm going to subtract 2 to both sides. 5x squared is equal to negative 2. Then I'm going to divide by 5. X squared is equal to negative 2/5. And then my last step to get rid of that x squared would be to do the square root. So anytime you do the square root when you're solving, you're going to get plus or minus. Because there's a negative under the square root, I'm going to bring out I. And then I'm going to go ahead and leave 2/5 underneath the square root, and that is fine as an answer. So that would be our first answers, positive and negative I, square root of 2/5. Then over here, to solve, I would add 2 to both sides, and I get 3x equals 2. Divide by 3, x equals 2/3. So those are my solutions. You factor, set your factors equal to 0. And remember, anytime there's a negative under square root, just bring out I. You can leave that fraction 2/5 under the square root. Number 22 is very similar. We're going to check for GCF to see if there's anything we can divide out before we start. Nope. And then we have to see that there's 4 terms, so we're going to be using my factoring by grouping the first 2 and then the last 2 terms. So looking at the first 2 terms, my GCF would be 7x squared, because that is the greatest term we can divide out from both. So I write down 7x squared and then divide out. 21 divided by 7 is 3. X cubed divided by x squared is x. Negative 7 divided by 7 is negative 1. And these x squareds cancel. Over here I have a positive leading coefficient, so I'm dividing out positive 5. So I write plus 5 and then open parentheses. 15x divided by 5 is 3x, and negative 5 divided by 5 is negative 1. So again, the numbers here multiplying out in front, merge together. 7x squared plus 5 is our first factor, and then 3x minus 1 is our second factor. So to solve, I'm going to take my factors and set them equal to 0. So 7x squared plus 5 equals 0, and 3x minus 1 equals 0. And then I move everything away from x. Subtract 5 to both sides. Divide by 7. So x squared is equal to negative 5 over 7, and your last step is doing the square root. Again, when you solve and you have the square root, it's always plus or minus. The negative under the square root will come out and be I. You can leave 5 over 7 underneath the square root because it can't be simplified. And then over here, we're adding 1. So 3x equals 1, and then dividing by 3, x is equal to 1/3. Okay. Number 23, we are going to be graphing the polynomial. So this is multiple choice, and we can see these are going to be our options. So in my class, I always had everyone graphing with a table and 5 points. So I actually am going to use that method. We don't necessarily need to do all 5 points, but we can look at that. So we're going to figure out first the shape of the graph or the end behavior. So whenever we want to figure out end behavior, where the graph is starting and ending, we look at our degree. We look at the largest exponent. So we're going to be looking at this term that has the largest exponent. So my degree for my graph is 3, which means it is going to be an odd degree. So it's going to have different end behavior. This is a positive leading, or not leading, positive leading coefficient, +1. So this is going to be our positive odd degree, where it's going to start on the left down at the bottom and end at the top right. So our graph will be rising, ending at positive infinity. So if I were to go ahead and make a table with 5 points, I could pick any points and then plug them into my graph to see where they would be. Because anytime you plug in x, you get y, and you'll have an ordered pair. So if I plug in -2, it would be -2 right here, minus, replacing x with -2 squared, plus -2 cubed. So -2 minus -2 squared, which is +4, plus -2 cubed, which is -8. Because -2 times -2 is 4, times -2 is -8. Then combining like terms, I get -14. So I know -2, -14 is going to be a point on my graph. So I'm going to go ahead and look to see where I might have that. -2, -14, where the graph starts down on the bottom left and ends at the top right. So I'm going to see if we have that so far. Starting on the bottom left, ending at the top right. A looks good. B is the negative, so I'm going to cross out B, and plus that is not going to give us a point, -2, -14. That's not going to happen. That's positive up there. -2, -14 will be down here, and so C might work. Again, this is a positive, and then this is the negative because it's falling and ending in negative infinity. And again, that point we just found, -2, -14 is down here. My graph is not going to cross through that. So I'm going to eliminate B and D. If I were to plug in -1, I could get another point for the graph. But I'm going to go ahead and skip down to 0. If I plug in 0 for my x terms, I'll show that work up here. -2 minus 0 squared plus 0 cubed. The 0 goes away and gives us 0. 0 is going away, and we're left with -2. So 0, -2, that's going to be my y-intercept. I can actually look at that at my available options. 0, -2 happens only in part A. It does not happen. This is 0, +2. So I know that A has to be my answer because of that point, 0, -2. And also because of this end behavior, starting down here and ending up here for the positive odd degree. Number 24, we're considering the graph of this polynomial that they showed for us here. We're going to write the polynomial in factored form. That means we need to factor the polynomial. So here it is. Since there are 4 terms, we are going to be factoring by grouping the first 2 terms and the second 2 terms. So from the first 2 terms, I can't divide out a coefficient, 2 and 5, but I can divide out x squared. So I'm going to write x squared and then open parentheses, and I'm left with 2x. So 2 is nothing dividing away, and then 3 minus 2 is 1, so x to the first power. 5x squared divided by x squared, those cancel to give me +5. And then we'll do the same thing over here. Over here, I have a negative leading coefficient, so I'm definitely dividing out a negative, and the largest number from 6 and 15, it's going to be -3. So I write down -3, open parentheses. -6 divided by -3 gives us 2. Write down x. Negative 15 divided by negative 3 is positive 5. So again, you take these, merge them together. That's your first factor. Then 2x plus 5 is my second factor. So that is how you would write the polynomial in factored form. They just want you to factor. We're going to state the degree of the polynomial. Remember, the degree is the largest exponent. So looking at the original polynomial, the largest exponent right here, 3. So it's a degree 3. We're going to state the coordinates of the polynomial's roots. So the roots are going to be the x-intercepts. So what I'm going to do is I'm going to solve by setting the factors equal to 0. So I already have my factors right here. I'm just going to set each one equal to 0. Here I'm going to add 3. X squared is equal to 3. Square root to get x by itself, I get x equals plus and minus square root 3. So to write these as coordinates, since they are x-intercepts, it's going to be positive square root 3 comma 0. Since it lies on the x-axis, the y is 0. And negative square root 3 comma 0. So those are going to be our first two roots. And then over here, subtracting 5, dividing by 2, x is equal to negative 5 over 2. We're going to write that as a coordinate, which is x followed by 0 because it is an x-intercept. So y will always be 0 for your x-intercepts. So those are our three answers. And then we're going to state the end behavior. So stating the end behavior, they were nice enough to actually show a graph for us. So for the graph, right here, we want to tell what the function is doing when x approaches negative infinity. So x approaches negative infinity on the left side of the graph because those are my negative x values. So we look to see what our function is doing. Our function is going down to negative infinity. So I will fill that in for the end behavior. As x approaches negative infinity, my function's approaching negative infinity because it's going down. And then as x approaches positive infinity, that just means the right side where you have positive x values, my function is going up towards positive infinity. So I fill that in right here with the positive infinity because it's going up on the right side. You guys can memorize that if it is a positive odd degree, like this one was, it would always match up. These negative infinity, negative, and then positive and positive. We are going to write an expression that is equivalent to this. Oh man, we got lots to go. Okay, take a deep breath. Okay. All right, I'm going to be combining like terms. So I'm going to start with this, and I'm just going to rewrite it. I'm adding it to this, so I don't need to change any signs. I'm just going to add them all by writing them down. Then I'm going to distribute the negative to all of these terms. So it gives you negative x squared plus 3y squared plus 2x. So all the signs change after the negative. So what we need to do is write this in the fewest number of possible terms. That just means combine like terms. So I'm going to start with the x squared terms, and I'm going to cross them out or underline or circle them as I go so that I don't leave any of them out. So looking at 4x squared, I'm going to look for other x squared terms, and I have one right here. So I have, oh, there's another one right here. So I'm going to combine 4, 1, and negative 1 to give me 4x squared as my x squared term. 4 plus 1 minus 1 is 4. So I'm going to go ahead and cross those out. We took care of those. All right, then I'm going to look at my x terms, I guess, or my y squared terms. I guess it doesn't matter. Let's look at the x terms. So I'm going to look at negative x and negative 4x and 2x. So negative 1 and negative 4 is negative 5. Negative 5 and positive 2 is negative 3x when I combine those. And again, I'm going to go in and I'm going to cross those out. Then we can do our last y squared terms. So I have 5y squared. Negative 2y squared gives me 3y squared plus 3y squared is 6y squared. Just combining those coefficients. 5 and negative 2 is 3. 3 plus 3 is 6y squared. And that's your answer. And the fewest number of terms. Just combining those like terms. Okay. 26 is over here. We are going to solve the following function. And again, we're following our procedure. We're going to factor and then set your factors equal to 0. So this is x to the 4th power and x squared. So when I'm doing this, I'm going to follow my same procedure for factoring. It's just instead of x terms, I'm going to have x squared terms. So two terms that multiply to give us x to the 4th power. You can use 10 and 2, 20 and 1, 5 and 4. But 5 and 4 is going to work. So it's 5x squared and 4x squared multiply to give you 20x to the 4th power. So again, notice we're not writing x, but it's actually x squared to get us x to the 4th power. We're going to multiply 2 times 1 or 1 times 2. And this is going to need to add up to 13x squared. Remember that middle term. So when I multiply diagonally, 4x squared times 2 is 8x squared. 5x squared times 1 is 5x squared. And these signs both need to be positive to add up to 13x squared. So this is positive and positive. So my factors are 5x squared plus 2 and 4x squared plus 1. So again, to solve, you take each one of these factors and set them equal to 0. So I'm subtracting 2 to both sides. 5x squared is equal to negative 2. Divide by 5. X squared is equal to negative 2 fifths. To get x by itself, square root. So x is equal to plus or minus I, and the 2 fifths can stay underneath the square root because you can't simplify that. Again, the negative under the square root becomes I, and it's always plus or minus when you do the square root when you're solving. 2 fifths can just stay under the square root. Over here, subtract 1. 4x squared is equal to negative 1. Divide by 4. X squared is equal to negative 1/4. Square root, and we get x is equal to plus or minus I, and we're actually able to take the square root of 1/4. The square root of 1/4 is going to be the square root of 1 over the square root of 4, which is 1/2. So we actually are able to do that. So we get x equals plus or minus 1/2 I. Okay, so we can actually simplify 1/4. The square root of 1/4 is 1/2 because 1/2 times 1/2 is 1/4. And we just make sure to bring out I because of the negative. We're going to factor this polynomial completely. So whenever we factor, always check for GCF. There's a negative leading coefficient, so we're definitely going to be dividing out a negative, and we can also divide out 2 from both of these terms. So we'll write that down, and then what's left is x cubed. 128 divided by 2 is negative 64. Okay, so this is not done. We still need to factor this. This right here is the difference of two perfect cubes. So it's going to follow this formula, a minus b times a squared plus ab plus b squared. So I'm going to plug in a and b. So to find a and b, you're going to do the cube root of the first term. So a is going to be x, and then the cube root of the second term, which is 4. Because 4 times 4 is 16 times 4 is 64. So I'm not going to forget about that negative 2 out in front, and then I'm going to plug in x minus 4 for a minus b a squared plus ab, which means multiply, plus b squared, so 4 squared. And that is factored completely. Number 28, we're going to determine whether the functions are even, odd, or neither. So make sure that we're not mixing up this with looking at degrees. Don't look at the degree. That is not going to tell you if it's positive, negative, or neither. Okay? So when I do this procedure, I am going to be plugging in or substituting negative x for all x's to see how it relates to our original function, if it's even, odd, or neither. So if I look at this first example and I replace x with negative x, and then I simplify it, negative x to the 4th power, since that is a positive power, I know it's going to cancel out my negatives. So I get 2 x to the 4th power, because that's just going to stay as x to the 4th power, plus 1. And that is exactly the same as my original function. So that means this is an even function. Okay? So when you plug in negative x and you end up with the same exact function you started with, it means it's even. So looking at the second function, plugging in negative x, it's 5 times negative x cubed minus 2 times negative x squared. Following order of operations, negative x cubed, that's going to give us negative x cubed, because when I cube the negative, it's an odd exponent, it's going to keep the negative, and I can show you guys that. Negative x cubed means negative x times negative x times negative x. So these cancel out to give us x squared, but multiplying by that extra negative keeps it negative. Right here, negative x squared means negative x times negative x, so that gives us x squared. And then this is negative 5x cubed. When you multiply, multiplying right here gives us this. So how does that compare to my original function? Only one of the signs changed. It became negative 5x cubed, but this stayed the same. So since they all didn't stay the same, they all didn't change, this is neither, because only one changed. One sign changed. And then we're going to do this again for my last function. Let me grab my charger real quick, guys. Oh, this has been a long video. Okay, hold on just a second. Okay. So I'm plugging in negative x for this last function right here. So I have 4 times negative x raised to the 5th power minus 2 times negative x. So order of operations, again, I'm going to take care of this at negative x to the 5th power is going to stay negative. So it's going to be negative x to the 5th power. Because it's an odd exponent, 4 of these negatives cancel out, but 1 is left over, so it stays negative. And then negative 2 times negative x is positive 2x. So multiplying this for my last step, I get negative 4x to the 5th power plus 2x. So you compare that to your original function, and both of the signs change. This became negative, this became positive. So since both signs changed, we're going to say odd. Okay, so function stays the same, it's even. If only one of the signs change, it's odd. And then if all signs change, if all signs change, it's odd, but if only one, it's neither. So it's all or nothing. No signs change, even. All signs change, odd. If only one, neither. Okay, this is how tired I am, and you're probably tired too, so keep up the good work. Okay, we're writing an expression for area and perimeter. So this is going to take us back to geometry. It's important that we give this to you guys on the test so that we're making sure to remember this information. So let's start with the perimeter. I think people technically find perimeter to be easier. So I'll remind you that to find the perimeter, you add all side lengths in the figure. So we're going to be adding all of these side lengths, but there's more missing over here. So it's helpful if you kind of break it down into more than one shape. So I have a rectangle and I have a square. So this is a square. So if this is x plus 1, this is x plus 1, then this has to be x plus 1. If you look down here, this is x plus 5. So this length right here, let me use a highlighter. If this is x plus 5, then this length right here is also going to be x plus 5. So this entire side, if I combine these together and add these, it's 2x plus 6 for this entire side length. So we'll use that. And then we want to figure out what this side length is. So if we break this down, you can see that since this is x plus 1, then this must be x plus 1 over here. And then since this is 2x right here, then this over here is also going to be 2x. So if you add these together, combining like terms, it's 3x plus 1 for this side length. So now I have all of my side lengths. I'm going to add them together. So I'll start with this one. X plus 1 plus x plus 1 plus 2x plus x plus 5 plus 3x plus 1 plus 2x plus 6. So I added all the sides. This plus this plus this plus this plus the entire thing here plus this entire thing. That is what I added together. So all I'm going to do now is I'm going to combine like terms. 1x plus 1 is 2x, plus 2 is 4x, 5x, 6, 7, 8x, 9, 10x. If I combine my x terms, and then my constants, I have 1 plus 1 is 2, plus 5 is 7, 8 plus 6 is 14. I'm just going to double check that because I got something different before. Yeah, 10x plus 14. So that is our expression for perimeter. We just added up all of those side lengths. So now we're going to look at the area. So the area is when we're going to be bringing in multiplication. So what we're going to do, we can't find the area of this. We're going to break it down like I said before. We're going to find the area of the square and add it to the area of this rectangle right here. So this will be our square. That's a square. And we're going to find the area of that. Then we're going to find the area of our rectangle. And we're going to add them together. That is how you find the area. Area of each, add them together. So we're going to break this down, first looking at the square. So if I look at the square, I have to remember the area formula for a square. The area formula for a square is side squared, or side times side. So to find the area of the square, it's going to be x plus 1 times x plus 1. So side times side. So I'm going to multiply that out. X times x is x squared. X times 1 is 1x. 1 times x is 1x. And 1 times 1 is 1. So now I'm just going to combine like terms. X squared plus 2x plus 1 is the area of the square right here. So I'm going to use that in a second. Let me now find the area of the rectangle. The area of a rectangle can be found length times width. So we're going to find the length and multiply it times the width. So again, we're looking at this green rectangle. My length right here is 3x plus 1. I'm going to use that. And I'm going to use the width, x plus 5. So it'll be length times width. 3x plus 1 times x plus 5. And then I'm going to distribute. 3x times x is 3x squared. 3x times 5 is 15x. 1 times x is 1x. And 1 times 5 is 5. Then combining like terms, I get this expression. So my last step, finding area, is you're going to add the square area plus the rectangle area, and you'll have your answer. So here's my square plus my rectangle, and all I need to do now is combine like terms. 1x squared and 3x squared is 4x squared. 2x and 16x is 18x. And 1 and 5 is 6. There is your area expression. Okay, number 30. This isn't enough space, so I am going to be using an extra paper to help us figure this out. So we have a rectangular courtyard containing a square fountain. So this thing in the middle is our fountain. That's our fountain. Okay, and then this is going to be our courtyard, this whole darkened area. The courtyard has a length of 5x cubed minus x squared minus 8x plus 8, and it has a width of x squared minus 2. The fountain has a length of x squared minus 5. We can't really write that in because of the darkened in area, so I'm just going to write it over here. X squared minus 5 is the length. Since they tell us this is a square, that means this side is also x squared minus 5, right? All the side lengths are x squared minus 5 for the fountain. All right. They want us to write an expression for the shaded area. So to find the shaded area, what we're going to do is we're going to find the area of the large rectangle, so that darkened in rectangle, but we have to subtract out the fountain. We have to subtract out the area of the fountain because that is not shaded in. So we're going to find the area of the rectangle and subtract it from the area of the fountain. So to find the area of the large rectangle, it's going to be quite a bit of steps. I'm going to be multiplying length times width because that is my formula for finding the area of a rectangle. So it's going to be x squared minus 2 times 5x cubed minus x squared minus 8x plus 8. So I'm going to distribute x squared to all of my terms, and then I'm going to distribute negative 2 to all my terms and combine. So x squared times 5x cubed, I'm going to write that way over here, is 5x to the 5th power because x2 and x3 add to give us x to the 5th. X squared times negative x squared is negative x to the 4th. X squared times negative 8x is negative 8x cubed. X squared times 8 is 8x squared. Then I'm going to distribute negative 2, and I get negative 10x cubed. Negative 2 times negative x is positive 2x squared. Negative 2 times negative 8x is positive 16x. Negative 2 times 8 is negative 16. Then I'm going to keep 5x to the 5th power and combine that term, and then I cross it out. Negative x to the 4th has nothing to combine with. I'm going to cross that out, write it down. Negative 8x cubed, and let's see, do I have another x cubed? Negative 10x cubed gives me negative 18x cubed. Then I have 8x squared and 2x squared to give me 10x squared. And then I have 16x that has nothing to combine with. And I have negative 16 with nothing to combine with. So this is my expression for the large rectangle. So I'm going to use that in a second. Okay, so now I'm going to find the area of the square fountain, which is my square. And the area for a square, the formula is side times side. So x squared times minus 5 times x squared minus 5. So I'm going to distribute that. X squared times x squared is x to the 4th power. X squared times negative 5 is negative 5x squared. Negative 5 times x squared is negative 5x squared. Negative 5 times negative 5 is positive 25. So all we need to do now is combined like terms, and this is my expression for the area of that square, the fountain. So my last step is going to be to take the area of the large rectangle or the courtyard and subtract it from, or subtract the area from the square area from the fountain. So I'm just going to do that quickly on this separate sheet of paper. It's going to be all of this, whoops, x to the fifth, and I'm subtracting x to the fourth power minus 10x squared plus 25. So remember, when you're subtracting, so here's my first expression minus the second. When you are subtracting, it is very important, unlike what we were doing for area and perimeter in number 29, you have to switch all of these signs because of the negative. So this is going to become minus x to the fourth power, positive 10x squared, and negative 25. So that is what you get when you distribute the negative. These signs change. And now I'm going to combine. So looking at my largest exponent, 5x to the fifth power has nothing to combine with. We're just going to write it. Then I'm looking at my x to the fourth power. I have negative 1x to the fourth power and negative 1x to the fourth power to combine and give us negative 2x to the fourth power. Then I have negative 18x cubed, and it doesn't look like there's any other terms, so negative 18x cubed we're going to copy down. Now looking at x squared, it's 10x squared and 10x squared to give me 20x squared. And then my x terms, I have 16x with nothing to combine with, and negative 16 and negative 25. I'm going to add those and keep the sign, and I get negative 41. That is my answer. Okay, last question. Number 31. We are looking for the graph for the values of x that are greater than 0. So we're looking for, in this graph, what is above 0. So I am going to highlight what is greater than 0. So we have this part of our graph, this part of our function, and then this part of our function is greater than 0. These parts are underneath the x-axis, so those are all negative. So this part would be all of the values that are less than negative 1 because they're to the left of negative 1. These are the values that are less than negative 1. So we want that first. X is less than negative 1. So one of these, okay? Then right here is where x is greater than 1 but less than 3. So our answer is B.